Rails and comments, do we even cover them? I guess not part of the parts.
So like the answer is usually no. Like we don't grade English. So kind of the official answer is like this. We don't like we cannot grade on comments, and that's just because like if we do, then people start writing essays that like it's impossible. And like it's like not just hard, it's like impossible to do it fairly either. And I don't think it makes sense. With that said, what we say is that if you write some code, if you feel like giving an explanation for what you're thinking, we're not going to grade it, but it can help us understand what you're thinking. So like if you don't have anything, then English is not going to do anything. If you have something, again, like we are going to grade it regardless of whether it has comments or not. And like if we didn't understand what you're going for and you come to us later and say, well, like actually this was like my partial solution, and according to the marking scheme, it deserves this amount of partial credit, we'll give it to you if that's true. But if you write an explanation in English, it might help us to understand what you're thinking right away. So it could be helpful, but it shouldn't be a priority to write the comments. So like officially the answer is we don't give, and not officially, like we don't.
I can just write comment, you get partial points.
They said that you can or that you cannot. They might think that I'm nicer than I actually am. So okay, all right. So I'm gonna do like the put sequence on board thing, I guess. Sorry, so is that did you look sorry, so you asked about the project. So like did you do the put sequence on board? Like is that gonna be helpful or okay, let's try it. It's not gonna be that yeah. So okay. So this is the starter code. So here is put sequence on board. So we start with a board, and then sorry, so I'll just print it. So board looks like this, right? So it's just a list of lists. Does that make sense? So then what put sequence on board does, so let me run this. So here I'm saying y is 5, x is 2, dx is 0, dy is 1, length is 3. So what that is going to do is it's going to put this sequence over here. So what this means is put the sequence that starts at y equals 5, x equals 2. So that's over here. And then the length is 3. And then the direction along the x-axis is 0. Direction along the y-axis is 1. So 0 means like you're not moving horizontally. 1 means you're moving in the positive direction along y, like this. So you start at 5, 2, and then you go to 6, 2, and then you go to 7, 2. Does that make sense? Does the setup make sense?
So like everything on this after the first one, like this.
Forget the moves. We're not doing moves. We're just doing put sequence on boards, right? So like the job of this function is to say we're putting this sequence that starts at coordinate 5, 2, and it goes in direction 0, 1, and 0, 1 means down because you are increasing the y coordinate and the x coordinate stays the same. Is that making sense? Okay, so let's look at the function. So what we're doing is I times, we're saying put this color into board YX, and then change Y by DY and change X by DX, right? So we start out at YX equals to 5, 2. And then we're saying increase Y by 1. So Y plus equals DY. And X keeps being the same because X plus 0 is still this. So that is like this. So then Y becomes 6, X is still 2. And then Y becomes 7 and X is still 2. And every time we're putting COL, so B or W, into board YX. Is that making sense? Okay, so now what we want to do is we want to do is sequence complete, right? So the idea here is to say, okay, a sequence is complete if and only if when we give this kind of sequence, so for example, this one, and we say this is supposed to be a sequence of length 3, this is actually a sequence of length 3, rather than, you know, maybe there is like another white over here, or there is another white over here. Right? So is it actually a sequence of length 3, or is it like a subsequence? Hey, does that make sense? So, okay. So let's write this. Forgot if I said that it should have color. Oh, it should be, so the color goes like this. So I'll just copy this. And that's going to be like this. So, okay. So we need to know whether it is an actual sequence and whether there are stones of the same color on either side, right? So here's one way to do it. So we're still going through the sequence, and we're just going to check, is this the color or not? So if not, then it's not even a sequence. So we return false. Right? So instead of putting COL here, we're saying if it's not, then return false. Right? The other thing that we need to do is we need to check on either side of the sequence whether there is another stone of this color. So over here, for example, we need to check this square. And we also want to check if this is a tall square, whether it has a white stone in it. Right? So, okay, how can we do it? So basically, there's two kinds of situations. So one is the location is outside the board, one is it's inside the board. So let's just do it. So we'll have below X and below Y below X. And that would be this coordinate. So this coordinate would be Y start minus dy, X start minus dx, right? So the idea is this is the starting coordinate, and then we'll check, okay, like what's the coordinate over here? Well, to go here, we add dy dx. To go here, we subtract dy dx. Right? And then we'll also have like an above y and an above x. And that is going to be whatever this is. So how do we compute this? Well, one way to do it is to say, okay, so we have y start, and then we add length times dy, right? So the idea here is that if we want to go from 5 to 8, that is 5 plus 3. So 5 plus 3 times the dy times the direction. Does that make sense? So stop me if it doesn't make sense. Okay. So the same with x. And now we just check. So the two situations are below y, below x is outside the board, in which case it's all fine. If it's inside, we need to check whether there is a stone there, right? So, okay. So we'll say if, so let me define inside board. So that is going to be right. So if both are between 0 and board length, but less than board length, then it is inside the board. If not, then it's outside the board. So I'll just check if it's inside the board. Then I'll check if it's inside the board, is the color the same as COL, in which case it's not complete. And similarly, oh, sorry, this is below y, below x. And similarly for above. And then if I've never returned false, then I checked all the possible ways in which it could be not complete. So it is complete, so I returned it. Yeah. Yeah, so this is the direction of the sequence or of the row, right? So if we're saying that we have a sequence that starts at coordinates 5, 2, and then we have a direction. So the direction in this case is dy dx is 1, 0. So the direction basically says, okay, like we're going this way along the y-axis. So kind of we start at 5 and then 6 and then 7. And then we don't move along the x-axis. So that's why dx is 0. And the way we operationalize it is we start at this stone and then we say, okay, y plus dy, x plus dx. So we move by 1 along the y-axis. We don't move along the x-axis. And then we do it again. Does that make sense? That's color, COL.
Oh, okay, no.
Yeah, sorry, yeah, that's confusing. Okay, does that make sense? So, okay. Hello. So, kind of a little bit young for engineering, but I said, they know what's good for them. Okay. So this is kind of given to you, and this is actually kind of a useful function to have. But in terms of doing the project or like getting started with the project, basically what you're doing is this style of thing over and over again, right? So what you're doing is you're going over the rows, going over the columns. And this is the process that you use in order to traverse the rows, the columns, the diagonals. So one thing that I would add here is, let's say that instead of a board, you just have a list, right? So you have like L and it's like, ones and zeros. And you're asking like, something like this, right? So, and the answer here is, two of them, right? So how would you do it? Well, there's like multiple ways, but one thing you can do is you could just say, okay, I'll go through L and I'll keep track of the running tally of how many ones have I seen so far. And then if I encounter anything that's not a one, then I reset, right? So the idea here is I start here, so it becomes one. And then I'm here, so okay, didn't find anything, so it's zero again. And then it's like one, and then two, and then three over here. And then I say, okay, is this a complete sequence? And if it is, I found my sequence of 3 ones, right? And then I keep going. So let's write this. So I'm going to say, all right, so tally is 0. And I'm going to say if L at I is 1, I increment the tally. If it's not, I set tally back to 0. Okay, does this make sense so far? Are you with me? Okay. So, all right. So now we're going to say, okay, if tally ever becomes 3, then we found our sequence of 3. Possible, because it might not be complete. So what do? I just check. Is this a complete sequence? Is this not a complete sequence? Right? So I'm going to say if I is length of L minus 1, that means it's complete. Or L at I plus 1 is equal to 0. Then I know that I found a genuine sequence of 3, right? So just increment count by 1. And then also at this point, I'll reset the tally to 0 because I'm either done anyway, because I got to the end of the list, or the next one is 0, so tally is gonna become 0 in a second. And don't actually need it because it will be set here as well, so I'm not gonna do it. Okay, so that's kind of answering the question of how many sequences of 3 are there. So in the project, there's 2 complications. So one of the complications is in this list, you're always going to the right. On the board, you're going, right or down or main diagonal or left diagonal. The other complication is that you're not just counting how many sequences of 3 there are, you're counting how many open sequences, how many semi-open sequences there are. but the principle is kind of the same. The other thing is here, the way we traverse the list, if we just set for I in range length of L, because we're always going right, so we don't need to bother with dy dx. In the project, you're doing something like this, where you're also saying for I in range length, but the way you keep track of where you are is you keep adding dy dx to yx. So that's basically, like try to digest it, come back to me if you're still stuck. So that's basically everything except for the last thing on the project. The last thing on the project is the same as tic-tac-toe, where once you're done with the functions that count up the open and the semi-open sequences, you try every possible move.
So how would we do it like diagonally? Because I kind of understand like up and down and the axis.
Oh, it's exactly the same. You don't even need to think about it because it happens automatically, right? So if the direction is dy1, dx1, then what happens is, like if you start, for example, from 0, 0, then you go to 1, 1, then you go to 2, 2, then you go to 3, 3, and so on. So the code works exactly the same. It's just that you specify that the direction is dy is, for example, dy is 1, dx is 1, or dy is 1, so you're going down here, and dx is -1, so you're going in the negative direction along x, so that would be a diagonal that goes like this. So that's just automatic. You just specify the correct dy dx.
Back with the list, I didn't, why do you think UI is like no bias?
So that's because there's two ways for the sequence to be complete. So one way for the sequence to be complete is if the thing to the right is 0, so that's this condition, or if this is the last thing in the list, in which case that means that I is the last element.
Like why would it be if I was just equal to like no?
It never would be, right? Because it goes from 0 up to the length -1.
Oh, because
Yeah.
All
right. It's gonna be good.
I felt my test. This is super long.
All right, so let's maybe finish up the session and then.
Okay. Oh, I thought you finished that.
I don't know. So, do people have other questions? Like, is this enough to get started?
Yeah, I think so.
Okay.
Is the comments online or like if when you run that the first time, so it's supposed to have an error, it's supposed to run.
It is supposed to have an error because like the function is not. Yeah.
So I never made it, but to access the slideshow, the new one, how do we get to it?
Is it not?
Like I know there's the link at the end of the
Yeah.
old slideshow, but is there another one? Because that one isn't working for me, but I saw that you changed it. So
Okay, sorry, I'll like organize it tomorrow. It's like I don't know because like some people accessed it and then you're not the only one who complained that it doesn't work, but I don't know why. Sorry. Okay, let me just do it now.
Thank you.
Yeah. Yeah, I'm sorry about that. Oh, that's week 8. Can you try?
is the actual link that all changed after?
No.
on my end.
Like, is it still not working or? Okay, let me. Oh, a tuple is like, so we'll do it tomorrow. So a tuple is like a list, except in round brackets. So
Someone says my function.
yeah, it is immutable. Yeah. So
Oh, okay.
yeah. Okay, this is a different URL, so maybe try that. So I pasted it and yeah, okay. Yeah, all right. All right. Any other points of discussion? Okay, all right. I'll take a look at your code and I'll stay to answer any questions. Stop the recording.